Are you an installer who wants to know how to connect Fronius transformers correctly and what you need to keep in mind, and thereby enjoy maximum convenience in use and handling? Then this webinar is the exactly right thing for you. My name is Dominik Kormani, and together with my colleague Robert Reinbrecht, who is behind the camera, we will guide you to the next 30 minutes.
Before we start, I would like to tell you to feel free to ask your questions in the chat at any time as already mentioned. And of course, your opinion is important to us, so please give us your feedback at the end of the webinar. So let's take a look at what's on the agenda today. At first, we'll look at the 3 Fronius smart meters which are relevant for our current transformers. One is the Fronius smart meter 50 kA 3-phase. The other is the Fronius smart meter TS 5 kA 3-phase. And finally our newest smart meter, the WR, which stands for wide range. The second point we will cover today is the installation and correct connection of the Fronius current transformers, the so-called smart meter CTA and V. And next, the configurations that has to be carried out on the smart meter display itself. This would be the CT ratio, so the transformation ratio, and also the Modbus address. And of course, we take a look at the selection criteria you need to consider in order to make the right choice in current transformers. And finally, troubleshooting in Solar.web to be able to see at any time if the current transformer has been connected correctly or not. So, the Fronius smart meter. Let's quickly summarize again what this Fronius smart meter is needed for. The smart meter is the heart of a system, so it is needed to record all energy flows in the household in which the system is installed, and to enable monitoring or load management, and many other things, such as implementation of the Ohm pilot to use PV surplus for hot water production, or also for emergency power supply with a battery. What is also special is that this is a bidirectional meter that not only measures the consumption data but also the feed-in data at the feed-in point. So it differentiates between self-consumption and grid consumption. And here you can already see the 3 smart meters that are relevant for our Fronius current transformers. One is the smart meter 50 kA 3-phase. The other is the TS 5 kA 3-phase and the new smart meter WR. The both on the left side are intended for large 3-phase systems. The 50 kA version is suitable for larger systems up to 50 kA and the 5 kA version up to 5 kA current. And the WR on the right side is for single and also for 3-phase systems, for residential and also commercial systems. The smart meter on the left is the older one, also the older version without the touchscreen, and the one on the right is the new version with the touchscreen, and TS in the name stands for touchscreen. And the WR is our newest smart meter, which replaces the 3 older UL smart meters. So in this case, WR stands for wide range. And in terms of functionality, accuracy and all these things, the 50 kA and the 5 kA smart meter are fully the same. The big difference is the display and the position of the buttons. And also the wide range smart meter has the same functionality, accuracy like the older UL ones. So here we have now the wiring diagrams. So let's start with the 50 kA smart meter and let's take a quick look at the whole thing in detail. The connections of the phases coming from the mains are clearly shown here above. So here we take the individual phases for voltage measurement from the available phases and the neutral conductor and connect them to the smart meter at the pins 2, 5, 8 and neutral on pin 11. Then there are the pins for each phase for one current transformer each. So the correct transformers are connected to the pins 1 and 3, 4 and 6, 7 and 9. And for the data communication, a 3-pole Modbus R2 cable is required So here please use cut 5 or higher, as the cable, as we need a twisted pair between M0 minus and M0 plus, and the cable itself must be shielded, so cut 5 is definitely the best option for you. And here we connect pin 35 with ground, pin 34 with M0 minus, and pin 33 with M0 plus. And ground the shielding on one side by connecting it to shield. And it is very important that the 120 ohm resistor included in the delivery is connected between pin 33 and pin 34, so please don't forget to connect this resistor. So the termination must also be set on the pilot of the Gen 24, because both components are located at the end of the Modbus line. The termination herefore is located directly on the pilot above the Modbus connection, where there is a small dip switch that must be in position 1, so please also pay attention to whether Modbus 0 or 1 is used in order to activate the correct switch. And at the new smart meter, the resistor is set with a bracket between pin 10 and 12, but we will look at this in more detail on the next slide. So here we have the wiring diagram of the 5 kA smart meter, so let's also have a quick look at it in detail. The connections of the phases coming from the mains are clearly again shown above. So here we take again the individual phases for voltage measurement from the available phases and the neutral conductor and connect them to the smart meter. Then come the pins for each phase again for one current transformer each. And the current transformers in this case are connected to the pins 4 and 5, 6 and 7, 8 and 9. And below we can see that a power supply connection is necessary for this smart meter. So it has to be powered by neutral and phase, or it can also be powered by DC, but I have it installed normally in the terminal box, so there is of course a phase available. Then just branch off there and connect it to the power supply. And like already mentioned, with this new smart meter, the termination can be set by a bracket between the pins 10 and 12. So here you don't need a 120 ohm resistor like with the older smart meter. And for the data communication, there is not much more to say. I think it is the same as with the 50 kA model, so just connect the Modbus RTU line again, and please do not forget to set the termination on the pilot again. And now let's check the wiring diagram of the wide range smart meter. Here you see again the 4 phases coming from the grid, which are connected to the smart meter to L1, L2 and L3 and neutral. So on this smart meter the connection is very logical because it is printed on the front cover of the meter. So for the current transformers, you connect again each phase for each current transformer and connect them to CT-L1, L2 and L3 pin. And here you connect the white cables from the transformer to the white pins and the black ones to the black pins. And for the data communication, you see these 2 pictures on the right side. The top one is for the snap inverter. Here you connect D minus to D minus, D plus to D plus, and minus to minus, like it is shown in the picture. And for the data communication at the Gen 24, you connect D minus to M0 minus, D plus to M0 plus, and minus to ground. So you can see the connection is very simple at this smart meter. And of course, after connecting the smart meter, it is important to set the transformation ratio correctly. And we will now look how to do it. So depending on which current transformer you choose, the transformation ratio is different. So let's start with the 5 kA TS variant. Here on the right you can see the display of the smart meter. So it has 3 buttons with which you can make the configurations. So to change the transmission ratio, we hold down the button in the middle for 2 seconds on the smart meter and select P1, which is normally automatically selected. If not, select it with the up or down button, and here you have then to enter the password. It is in this case 2633, and then hold enter for 2 seconds for confirmation, and then you select the menu P4 with the up button and hold down again enter for 2 seconds. Then it says CT ratio. This stands for transformation factor. So the ratio then has to be set here depending on the transformation ratio I have. So the factor is calculated as follows from the primary to the secondary coil. So as you can see here in the example, I have 50:5 from primary to secondary as the ratio. So the factor to be set is 10. However, this is always printed on the side of the current transformer itself, as you can see this in the picture. And it is similar with the older 50 kA smart meter. Here you have to press P and arrow buttons at the same time, and then the smart meter should request a code, which is in this case 0001. And to set this code you have to navigate to the correct position with the arrow button and then press P to count up 1 digit at a time. And once the correct code has been entered, confirm it again by pressing P and the arrow button at the same time. And after this step, the smart meter should open the menu for the CT value. So here we have taken a ratio of 50,000 to 5 as an example. So which means that our CT value is 3000. And we set exactly this value by navigating with P and the arrow button, and then confirm the settings by entering the arrow and the P button at the same time. And now you have also set the CT value correctly for this smart meter. The next setting, which also could be very important if you use more than one smart meter in one system, is the Modbus address. So the first smart meter at the feed-in point is always with the Modbus address 1, and any other smart meter has to have another address. So now let's see step for step how to change the address at the 50 kA smart meter. At first you hold down P and the arrow button at the same time, and then you enter the password 2633, and here you hold again down the P and the arrow button at the same time to switch to the menu item address. Then you set the correct address and confirm it by pressing the 2 buttons again at the same time. Now the Modbus address is set. At the 5 kA smart meter you have to press and hold enter for 2 seconds, and then select the menu P1, which is normally automatically selected, and enter the password 2633. Then hold again enter for 2 seconds for confirmation, and then you have to select the menu P14 with the up buttons. Once you have selected it, you hold again enter for 2 seconds, and now you are in the menu where you can configure your Modbus address. So here you have to set the correct address, hold down enter for 2 seconds for confirmation, and after this you select the menu P18, which is for closing the setup menu, and hold down enter for 2 seconds to complete. And at last, I'll show you how to do it on the wide range smart meter. Here you have to set the Modbus address via the dip switches on the front, as you see here in the picture. And in this case, each dip switch has its own value, as you see in the chart. And the sum of the turned on switches is the address. I have picked out 3 examples for you. The first one is the standard setting with Modbus address 1, which is always used if you have only one smart meter in the system, or at multi-smart metering for the smart meter at the feed-in point. In the second example, you can see what I told you with the sum of the turned on switches. So here the Modbus address is 3 because switch 1 and 2 is turned on, so 1 plus 2 is 3, so the address is 3. And at the example 3, you see clearly that each switch has its own value. Switch 3 has the value 4 and switch 5 the value 16, so the sum is 20, so the Modbus address is also 20. And be careful, pin 7 is the 120 ohm termination and pin 8 the baud rate. The next point is the selection criteria and what you have to consider at selecting. So it is important to note the self-consumption of the smart meter, which you can otherwise easily find out from the operating instructions. At the 5 kA smart meter, it is approximately 0.5 volt amperes. So this value is important because I have to take it into account when choosing the current transformer. So the power of the current transformer must be higher than the sum of the power of the Fronius smart meter itself, so the 0.5 volt amperes in this case, and the losses across the cables, so to say. So I have taken out a table here for you, an overview for you. So depending on the cross section and the length of the cable, I have a higher or lower cable resistance, and I add this to the 0.5 volt amperes of the smart meter, and the value that I get is the minimum power that the current transformer must have, and depending on this I can select the correct transformer correctly. But of course you can find this table also on our homepage. Here I have taken out another table for you. In it you can see which different current transformers we have, with the usual data such as dimensions, permissible cable diameter, cable length, in which temperature range we can work, and so on. And of course you can also find this table on our homepage. And what I would like to mention again is, please do not forget to set the transmission ratio on the smart meter, because it's one of the mistakes that happens very often. This slide is also very important. What should be considered? So firstly, the current transformer must match the voltage phases. So make sure that the current transformer L1 measures the current on the same phase that is monitored by voltage input L1. And the same applies to phase L2 and also for L3. So please pay attention to the correct installation direction. This is also printed on the bottom of the smart meter. And what is also important is that you connect the current transformer to the phase to be measured and connect the current transformer cables to the Fronius smart meter. We have already seen this before at the wiring diagrams, so I hope this is clear for everyone. And a very important point is, always switch off the power supply before connecting or disconnecting cables, and also never switch on the primary side if the secondary side is not connected to the smart meter, or the secondary side is short-circuited, or a load is connected. And last but not least, our current transformers are only suitable for use with Fronius smart meters. So the next point is troubleshooting. So if you do not observe these points, errors will occur. So therefore I would like to show you troubleshooting on Solar.web and how to recognize the errors. So the first step in case of a fault is that you should always check the installation direction and the phase sequence through the energy flow in Solar.web. So here we can see on the left how it should look like in the best case. The energy flow is correct, and therefore also the installation direction must be correct. And in the picture on the right you can see how it should not look like, because in this case of an error the measured power is negative or the production is the same as the consumption. So in this case the installer has connected two current transformers correctly and one current transformer incorrectly. You can see this very clear in the diagram that the current transformer of phase L1 measures a negative power, and the current transformers of phase L2 and L3 are connected correctly. So in this case the one current transformer which measures phase L1 should be corrected, so the direction has to be changed. Then this system will also run optimally. So yes, exactly, that was all of the theoretical part. So here are some further information. So as already mentioned, you will find all the operating instructions on our homepage, whether for the smart meter 50 kA or the TS 5 kA or the wide range smart meter, and of course also the data sheets and the tables mentioned earlier. You can also find videos about our smart meter on YouTube, in which the correct connection and other important details are explained. And you are also welcome to register for further webinars and online trainings on our homepage www.fronius.com, or take part in our present trainings in Wales. And as already mentioned, you can find all the necessary documents such as data sheets and so on our homepage under the point Downloads. You can also find the recordings of the webinars on YouTube. This webinar will also be uploaded in the coming weeks on YouTube. So this brings us to the end of our slides, and we will now take a few minutes to answer your questions. And apart from that, there is not much more to say. Thank you very much for your participation. Goodbye and see you the next time.